Have you ever thought about the different decisions that you could have taken? Ever wondered what your life could have been if you chose something you did not? What if I said there is a mild possibility the life you never had actually exists parallel to you? What if I told you the particles that made you can sense each other from a light year apart? These thoughts probably started with a cat that was dead and alive at the same time, expanded over time. Right now, we are putting humans in the place of the cat and bringing this to the next level. At the end of this video, there is a bonus. You will get to understand the basics of what is presumed to be the most complicated field of physics. There is a famous thought experiment done by Schrodinger, a famous name in the field of physics, using a cat. Now, imagine a cat being placed in a closed box with a radioactive substance. Within the first hour, there are equal chances the radioactive substance completely decays or kills the cat. After 1 hour, what do you think the result will be? Cat lovers may say the cat will be alive, and other opinions may suggest that the cat will be dead. Two possibilities, but no one knows which one of them is actually true until we open the box and find out. Hence, we can say the right answer is that the cat is either dead or alive. But no, that is not the right answer. You see, until you open the box to see the cat's condition, the cat is equally dead and alive, meaning the cat existed in both the states, but you forced one of the possible conditions by opening the box. So, technically we made our own life more complicated, but it helped us to get a new perspective about fundamental science as a whole. That thought experiment was necessary to tell us how things in the universe have a dual nature. Scientifically, an electron can be perceived as both a wave and a particle. It tends to exist with this dual nature where it works in two conditions at the very same time. Only when we choose to see it as either a wave or a particle, we are trying to ignore its dual nature. Like in the case of the cat, our choice is what brings us to the observed condition. Now, hold on tight to that idea. If you thought about this in a bigger or more philosophical way, we can say that everything we are experiencing is caused by our own decisions. And before we make these decisions, all of us are existing in a state where everyone is capable of experiencing all the many outcomes connected to all the possible decisions we can make. For example, when this video turned up on your screen, you had a choice to click or ignore it. Guess what? You clicked it and you're watching this video, but the fact that you won't be watching this video if you didn't click it is equally true and undeniable. So, confusingly, it is somewhat true that you're watching this video and not watching this video. This is where one of the most mind-bending theories can be connected: parallel universes. Spoiler alert, these are just possible conjectures with no concrete scientific evidence yet. Whenever there are choices, there are so many possible ways our life can change. Imagine your existence and timeline branching out every single time you make a decision. Simply said, in Schrodinger's thought experiment, if you open the box and find out the cat is dead, another timeline where you observed the cat alive has already happened at the very instant you opened the box. It's just that you don't know that happened. If one action can have such an effect, think about the major and minor decisions one makes throughout his life. All the possibilities have the right and probability of existing. These branched realities are nowhere but near us, existing with us. And the coexistence of all these possible realities is what we simply call as parallel or bubble universes. If they do exist, why can't we see them? There are two possible reasons. The most scientific reason is that all these bubble universes are at different natural frequencies. When you punch a wall, the molecules of the wall are vibrating at their fixed position, but you can't see them, only possibly feel them. That could be because our eyes are meant to notice events happening at a very particular range of frequency. These parallel universes are possibly vibrating at their very own range of natural frequency that we can't even see them. Before we could go any further, head on to our channel to find more interesting videos. Do not forget to subscribe to our channel and ring the notification bell so that you won't miss any of our videos. The second reason involves dimensions. It's a common but mistaken belief that we live in a three-dimensional world. What we live in is actually the fourth dimension, time, which explains why we can play with the first three dimensions naturally. In simpler words, if we wanted to label the position of an object in our universe, apart from the x, y, and z coordinates, we may have to consider the time coordinates as well. Having said that, evolution may have limited our senses to just the three dimensions, that we cannot even explore the parallel universes which are possibly existing at different planes on fourth or even the fifth dimension. But that's not the only crazy thing the thought experiment led us to ponder about. In fact, it was also the reason to a whole new discovery. Remember how we said particles can have a dual nature just before we indulged into the multiverse? These particles were also noticed to have a strange connection with each other. They interact in a way that their key properties are dependent on each other. This means that if you did something to one of the particles, the other related particles will be affected as well. Think of it like particles with one hive mind. The most shocking thing about these particles is that they continue to have a similar nature. Doesn't matter how far apart they are in the universe. Even at a distance of light years, they still somehow manage to connect with each other. If this is applied to a human scale, two astronauts on different planets can feel their connection between them. If one of them is hurt, the other will be hurt as well. Unfortunately, this miraculous property has its very own limits. The same scenario doesn't fit for large molecules, not even large atoms. Scientists believe that this peculiar and inexplicable effect disappears at a large scale. The only possible reason in the making is gravity. They say the dominance of gravity in the large scale of objects could be the reason this strange connection between particles exists only at an extremely small scale. Even then, it doesn't stop changing the world. At the very scale where this strange connection exists, we can use them to build computers far more efficient than what we can possibly imagine at the very moment. It has indeed fired up so many ideas, though many of them remain to be theoretical and fictional at present. Our imagination, after discovering this peculiar connection between these particles, has even led us to think about building computers in the size of protons. Imagine if we could alter the dimension of an object, if we could somehow unfold a proton and build a computer in it, the computer will be built in the size of a proton. As we build more of them, due to the strange connection between these protons, these computers can connect with each other naturally, with no effort, at any distance. It'll be like they are connected by a Bluetooth, but the distance will be infinite. They can keep communicating between each other, doesn't matter how far apart they are from each other. I mean, obviously this is fiction, but the basic logic is indeed true. And we wouldn't have even thought about this thing if it wasn't for the miraculous connection that we noticed thanks to a cat that never existed anywhere except in the mind of Schrodinger. If you reached this part of the video, you must have been intrigued by the mind-bending theories. So let's do something less mind-bending. Hit the like button, subscribe to our channel and drop your comments. Also, please share this video with whomever you think might find it interesting. You'll be doing a huge favor and keep us producing more content. Have you ever heard that quantum physics is the most complicated branch of physics? Well, today you had a taste of that branch. And what we call to be the dual nature of the particle is actually quantum superposition state. Remember the part where the particles had a strange connection between each other? That is quantum entanglement. True to the name, quantum vimana.